Alright, so we're going to be talking about solving systems of equations by substitution. So we've already talked about when to use each method. So looking at this, we know to use substitution if one equation is solved for one variable. So here, this has an isolated variable, x is by itself. So this is a good time to use substitution. Okay, so to substitute just means to replace. If I have a substitute for the day, I have a replacement for the day. So we are going to say x is equal to this piece right here. So we can take that piece and put it right here where x is. Okay. So then we're going to replace that x with 2y because they're equal, they are the same. So where x is, I'm going to put 2y. Then I can solve from there. So 5 times 2 is 10. 10y minus 2y gives me 8y. And then I know how to solve this. I can just divide by 8. Which gives me y equals 2. From there, I can solve for x. I can plug back into either equation, but this one is already pretty simple. So if I plug back into this top equation, the equation was x equals 2y. Once again, we're going to substitute. We know y is 2. So I have x equals 2 times 2, which is just 4. So 4, 2 is my solution. All right, moving on to the next problem. This one isn't solved for x, but the first equation here is solved for y. So I know y is equal to 2x minus 1. So wherever y is here, I can replace that with, that's not a very good arrow, I can replace that with 2x minus 1. So now I have x plus 2x minus 1 equals 5. That's 3x. X plus 2x is 3x. Minus 1 equals 5. I will add the 1 to the other side. Which gives me 3x equals 6. Divide by 3. And this one's nice also. We get x equals 2. And then I can plug that back into either equation. But the top one seems easier to solve for y. So, where x is in this equation, instead of writing x, I now know x is 2. So 2 times 2 is 4. Minus 1 is 3. Remember, x gets written first in an ordered pair, so we have 2, comma 3 is our solution. All right. Moving down. Once again, one of our equations is solved for y. So I'm going to take this piece right here and put it where y is in the other equation. And on these ones, it happened to be the first equation that had the isolated variable, but it can be either. Where the y is, we're going to put 5x minus 1. Make sure if you have any questions as they go along, you write them down so that you can ask them in class. Distributing, I get 10x minus 2, where you just take 2 times 5x, 2 times negative 1. We've done a lot of that. Okay. Next to solve, I can move the 10x or the 3x, but I'll move the smaller one just to keep things nice. Stay away from those negative numbers as long as we can. Okay. Add the 2 over, and I get 14. Divide by 7, and I get 2 again. That was nice. Okay, I can plug it into either equation, but the top one is solved for y, so it should be a little bit easier. We'll go y equals 5 times 2 minus 1, because x is 2. Well, that's 10 minus 1 is 9. So y equals 9. 2, 9 is my solution. Okay, now looking at the next example. Once again, this one's solved for y. Looks a lot like the last one. We're going to take that and plug that in for y. So we get 4 times 3x plus 1 equals 12x plus 4. Distributing here, we get 12x plus 4 equals 12x plus 4. We subtract the 12x from both sides, but it'll cancel on both sides. Both sides only have 12x. So I'll get 4 equals 4, which is always true. So this is one of those special cases. If you get down to something that is always true, we know that any possible combination, or that there's infinitely many solutions. The left side of this will always equal the right. So we have infinitely many solutions. Or we can write our real numbers. I don't care which way you write it, remember those are the same. I guess let's look at this last example here, and then I'll leave the bottom two to try on your own. And we'll go over them in class next time. So here I have y equals 3x plus 1. I'm going to put that where y is. So 4 equals 3x plus 1. 4 times 3x plus 1 equals 12x plus 3. So all I did was said y equals this stuff right here. So where y is, I'm going to put this stuff right here. Remember to put it in parentheses so that you remember to distribute. I get 12x plus 4 equals 12x plus 3. Well, this is a lot like the last problem, except here if I subtract 12x from both sides, I get 4 equals 3. That is never true, so this is what a no solution looks like for substitution. Meaning there is nowhere where these two lines will cross. Where this means that they are the same line, they lay on top of each other. So there's solutions all the way along the line. This one, they're two parallel lines, they never cross. Alright, complete the last two and come back with any questions and we'll go over it next time. Let me know if you need any help.